There we go. So starting over here on the right side, we're starting with 0 degrees. And we move in a counterclockwise direction. So 0, 90 degrees is up here at the top. And then far left side, 180 degrees. Down at the bottom, 270 degrees. And one full rotation around the circle, 360 degrees. So we should already know those important angles at the X and Y axis. These actually have a special name. They're called quadrantals. The quadrantal angles, very odd name, but the 0, 90, 180, 270, 360, that's what those are called. They're on the X and Y axis. So keep remembering that this is actually on an XY coordinate plane. Okay, so I did all of those in one particular color, and now I'm going to switch colors because I know that the X and Y axis cut my circle into 4 quadrants, 4 sections. Now we're going to go into each quadrant and cut it in half. So this 90 degrees here in quadrant 1, if I were to cut it in half, that means this is 45 degrees. So let me highlight this for a second. So that means this angle here is 45 degrees, right? It cuts that quadrant in half. That means this is another 45 degrees. So 45 and 45, that's what makes up the 90 degrees. If I keep going around the circle and I add to my 90 another 45 degrees, that would put me right here in the middle of this quadrant, in quadrant 2. And this would be how many? 135 degrees. And then if I add another 45 to that, does it equal 180? Yes. So everything's divided symmetrically all the way around the circle. So let's keep going. Let's add another 45 degrees. So in the middle of quadrant 3 here, if I add another 45 degrees to the 180, then what's my degree measure? Good, 225 degrees. Adding another 45 puts me at this quadrantal 270. And then one more time over in quadrant 4, I can add 45 degrees to that 270. And I'm at 315 degrees. And then 315, to add another 45, it should put me at 360. And so that's the way I can validate, okay, I know that I've done the right thing here. Okay, so that is what I would call the 45s, the 45 degree family. So those 4 angles there are all 45 degree angles all the way around the unit circle. If I were to take 45 degrees and use my conversion factor and convert it into radians, let's do that now. Convert 45 degrees into radians. Tell me how many radians 45 degrees is equal to. Remember, I would multiply 45 times pi over 180. Good. I end up with pi over 4. So pi over 4 is another way to describe that angle measure. Instead of calling it 45 degrees, I can call it pi over 4 radians. So this little blank here is for our radian measure. So I've said before that the unit circle is typically always in radians. So we need to get into the habit of not thinking of it as 45 degrees as much as thinking of it as pi over 4 radians. They are equivalent, but pre-cal, calculus, the default is radians. Okay, so pi over 4 radians, if I add another pi over 4, that would put me up here at the 90 degree at 2 pi over 4. So this one would be 1 pi over 4. The next one would be 2 pi over 4, but that's going to simplify. 2 pi over 4 simplifies into pi over 2, right? So this is pi over 2 radians. 90 degrees is pi over 2 radians. So we could go all the way around our circle and take each degree measure and do that conversion factor. That's one way to get the radians. Or we can simply count out like we did before. We continue to add pi over 4 each time I have a new angle that same measure. So I've done 1 pi over 4. Here's 2 pi over 4. That means the next time I add that many, I'm going to have 3 pi over 4. So 135 is 3 pi over 4 radians. And then the next time I add that size angle, I would be at 4 pi over 4, correct? And 4 pi over 4 simplified is just pi, right? So this is pi radians, 1 pi. All right, so 1, 2, 3, 4 pi over 4. Now the next time I add one of those angles, I'm going to have 5 pi over 4. The next one would be 6 pi over 4, but that's going to simplify, right? Good. 6 pi over 4 simplifies 3 pi over 2. Good. Six pi over 4, that means the next time I add an angle that's that measure, I'm at 7 pi over 4. And then one last time that I can add another one, that would put me at 8 pi over 4, which is really 2 pi, right? So this, see, this 4 goes into this 8 2 whole times, so it's 2 pi. So now we can see that half of our circle would be 1 pi radians. A whole circle is equal to 2 pi radians. Does that make sense to us? Okay. So we've learned, our most recent unit taught us that we can find the values of our leg lengths for any triangle that we have on the circle. We did that on our last assessment. And what we did was we would take that point, we would drop a perpendicular to the x-axis, right? We made a right triangle. We said, okay, this is theta. And so I could use SOHCAHTOA to figure out my my leg lengths. I just needed one more piece of information. Since we're on the unit circle, every triangle that's on the unit circle has a hypotenuse length of 1 unit, okay? The hypotenuse length here is 1. So with my hypotenuse length of 1, knowing that my theta is 45 degrees, or pi over 4 radians, I could then use SOHCAHTOA to figure out the 2 leg lengths. Instead of us actually doing that math and calculating that, I'm going to go ahead and tell you the values that we get for these. And we get, on this side, we get the square root of 2 over 2 as this leg length. And this leg length over here is also square root of 2 over 2. It's an ugly fraction, but that's the leg lengths. Now, we also did some examples where they would give me the coordinate point, and so by knowing the coordinate point, that told me my leg lengths. So that's what's happening here. See up here, they've got in parentheses, and they have this point. This here is the coordinates of that point on my unit circle. And so I went over square root of 2 over 2 to find the x coordinate, and then I went up square root of 2 over 2 to find the y coordinate. So the coordinate comes from the fact that we use our right triangle trigonometry to find the leg lengths of the triangle. That's where it comes from. And then we just take that and reflect it across the x and y axis to get all of the other angles that are in this family. Okay, so in the 45s family, or in the pi over 4 family, it forms like a little butterfly shape, basically. If all of these triangles that form, and you don't necessarily have to draw this on your circle, but just to give us since I can erase mine easily, I'll show it to you, the butterfly effect. So these are all the 45-degree angles around the circle, and they're all going to share those same coordinates. They're just going to change signs, like positives and negatives, depending on where they are. Okay, so now that I know my x and y coordinate here is root 2 over 2, when I reflect across the y-axis, this one over here at 3 pi over 4, the x coordinate's negative, right? Because I went to the left to get over here. So the x is negative, but the y will stay positive. So same x and y coordinates. The only difference is the x is negative. I'm in quadrant 2. So when I take that and then flip it over the x-axis so that I go down here to 5 pi over 4, same exact coordinates, but be careful with your negatives. Since I'm in quadrant 3, everything's negative. So I went to the left to come down here, and I'm going down, so both of them are negative. And then same x and y coordinate over here at 7 pi over 4. But in quadrant 4, my x is positive and the y is negative. Okay. So this is what we have so far. The explanation that I was giving about the leg lengths and the hypotenuse length is basically just to give you a little bit of background so that you understand where I got that weird fraction from, the root 2 over 2. So I'm absolutely open to explain it further if you are, if you're someone who enjoys math, enjoys the trig, and you want to understand better where it comes from or why, then don't hesitate to chat with me about it. And I'm happy to give you more detail, but for now I'm just going to plow ahead and pick another angle family and go around the circle. Okay, any questions? Let me stop here for a second and go back to my quadrantals, the ones that we had 0, 90, 180, and 270. Since now we know that this point over here is a point on the XY axis, same like this one here. These points are points on the XY axis. And we know that the radius of this circle, the hypotenuse for every triangle, is always going to be 1. So the coordinate over here at 0, which we can call this 0 pi radians, or we can call it 2 pi radians, we can call it 360 degrees. This is 1, 0. Does that make sense that if I were graphing this point on my XY axis, here's my XY axis, then to get to this point here, I go over 1 and up 0. So that's the coordinates there, 1, 0. Which means at the top, at 90 degrees at pi over 2, what would my coordinate be? Nice, 0, 1. And then at pi radians, 180. Very good. -1, 0. And then down at the bottom at 3 pi over 2, which is 270 degrees, 0, -1. Good. All right. Now let's pick up a different color and let's go around the circle with a different degree measure. And we're going to do 30 degrees next. So here I have 30 degrees. So each time I add 30 degrees means I then get my other special triangle. So 30, this is 30 here. If I add another 30, then I get this one here. 30 plus 30 means I'm going to have 60 degrees, right? Well, 60 is the other family that I'm using. So I'm going to switch back and forth between my colors here because they're different families. So I'm going to put 60 in a different color. But just keeping in mind that each time I add 30 as I go around the circle, I'm filling in 2 separate families. I'm filling in my 30 degree family and my 60 degree family. These are the special right triangles, the 30, 60, 90, and then the 45, 45, 90. You learned a little bit about them in geometry, which it's really kind of cool how all of that comes together to make up the unit circle. We could spend a whole day of class just discussing how the unit circle comes about. But for now, let's keep going. So if I add another, I was adding 30, correct? So if I add 30 more to 60, that puts me here at 90, right? If I add 30 more to that, I get how many degrees? 90 plus 30 puts me at 120 degrees. 120. Add 30 more. That puts me at how many?
150.
Good, 150. Nice. If I add 30 to that, I should be at 180. Okay, keep going. Add 30 more. Add 30 to 180. 210 degrees. Add 30 more. I'm at 240 degrees. Keep going. The next one would put me at 270. And then 30 more puts me at 300 degrees. And Again, I keep alternating my colors for the different families. Next, I'm at 330. And then finally, I get up to 360. So, with my highlighted sections here, we can see the two different families, the 30-degree family and then the 60-degree family. So their little butterfly, which again, you may want to add in later, these are the triangles that would be formed by the 60-degree. The 60-degree angles form these triangles around the circle. And it's just kind of pretty when they all are there and highlighted and such. But keeping in mind, the whole premise of all of this comes from our right triangles that we learned just by doing SOHCAHTOA. All right, so going back through to put in the radian measures. For 30 degrees, if I convert 30 degrees into radians, I get pi over 6. So 30 degrees is pi over 6 radians. So thinking like 1 pi over 6. When I add 30 more to 1 pi over 6, that means I would be here at 2 pi over 6. But that's going to simplify, right? To pi over 3. So if I add, let me put it out here if I do this. So we had 1 pi over 6. Here was 2 pi over 6. Another 30 would make me 3 pi over 6. Does that reduce to what I already have in that spot? Yes, so that just kind of helps confirm I'm doing it right. Add another, that would put me here at 4 pi over 6. Right? And that's going to simplify to 2 pi over 3. So now notice my two 60-degree angles that I have in purple. They both have 3 in the denominator, right? They're pi over 3s. Okay. I'm going back up to keep counting. So I stopped at 4 pi over 6. That means next this would be 5 pi over 6. And no way to reduce that. So that just is what it is. 5 pi over 6 at 150 degrees. And then I flatten out at 6 pi over 6, which is the same as pi. Again, 7 pi over 6. And that's not going to simplify at all. So 7 pi over 6 is at 210 degrees. And then next would be 8 pi over 6. And that's going to simplify. 8 pi over 6 is 4 pi over 3, which checks out, right? Because my 60-degree angles were over 3. So I'm doing good. That puts me at 9 pi over 6 down here at the bottom. 9 pi over 6 simplifies to what I already have there, 3 pi over 2, correct? So they are the same thing. 9 pi over 6 is the same as 3 pi over 2. They're the same fraction. They're equivalent. Just two ways of writing the same thing. Go again, add another. I'm going to be at 10 pi over 6. So 10 pi over 6 simplifies to 5 pi over 3, which is consistent with all my other purple ones. If I add another, that would mean 11 pi over 6, and that's not going to simplify at all. So 330 degrees is the same as 11 pi over 6 radians. And then just to finish it off, that would put me at 12 pi over 6, which is equivalent to 2 pi. So I've counted my way around the circle in radians. So it's kind of up to you. If you, I don't necessarily love memorizing things that can't attach somewhere in my brain to something else. So instead, when I first started to learn this, this is how I would fill out my unit circle every time. I would count my way around with my degrees. I would count my way around with my radians, and then go back and fill in the coordinates. It's up to you. There's tons of different tricks and strategies. You can Google the unit circle, and there's fun, silly ways to try to help you remember it. So I encourage you to find a way that works best for you. But this way, at least, you have some groundwork. You get to see why it is what it is, and then counting it out is just one method that can work for filling it in. All right, so going back over here, we need to know our leg lengths for the 30-degree family and the 60-degree family. And so we said we could figure that out easily because we know SOHCAHTOA. We know our hypotenuse is length 1 because my circle has a radius of 1. So every time I have a right triangle, my hypotenuse will always be 1. So that's enough information. With my hypotenuse length and my angle measure, I could use SOHCAHTOA and figure out the leg lengths, okay? So instead of us doing that, I'm going to go ahead and tell you what you would find. You would find that this long side here, the long side is going to be a length of square root of 3 over 2. So they're not pretty little whole numbers. They're fractions that have radicals in them, but they are going to stay consistent. So the long side of the 30-degree angle, it's going to be the same as the long side on my 60-degree angle. The long side, square root of 3 over 2, and the short side is 1/2. So that exact coordinate is going to reflect to all of my other pi over 6 radians. Okay, so I'm going to take the root 3 over 2. I'm going to copy that coordinate over here at 5 pi over 6. So root 3 over 2 is the coordinate for the x. 1/2 is the coordinate for the y. It's in quadrant 2, which means the x is negative. Because to get to this point right here, I have to go to the left, so negative and then up positive 1/2. So copy that same coordinate down here at 7 pi over 6. So this point here. And then what are my signs in quadrant 3? Yeah, they're both negative. Good. Quadrant 3, everything's negative. Okay. So one more time, over at 11 pi over 6, copy your coordinate for the family, root 3 over 2 and 1/2, and the y coordinate is negative here. All right. Now, what's nice, another little pattern that we can put to good use would be my pi over 3's. Pi over 3 is the same as 60 degrees, and it's simply the inverted x and y coordinates. So at 60 degrees or at pi over 3 radians, my coordinate is 1/2 and then root 3 over 2. So copy that over here at 2 pi over 3. We're going to have 1/2 and then root 3 over 2. And the x coordinate has to be negative. Okay. We'll reflect that over the x. So down here at 4 pi over 3, I've got my coordinate 1/2. Root 3 over 2 is the y, and both of them are negative. And one more. 1/2 root 3 over 2. This is the coordinate at 5 pi over 3. And the y coordinate is negative. Okay, now another really important thing to point out that we're going to use as we use the unit circle is those x and y coordinates. We found those from the leg lengths, right? And how did we get the leg lengths? Well, we had to use SOHCAHTOA. We used SOHCAHTOA to get them. So what happens is every single coordinate all the way around this circle, every single time, no matter what, the x coordinate is the cosine of that angle measure. And the y coordinate is the sine of that angle. So if I'm asked, for instance, what is the cosine at 45 degrees? What is the cosine at pi over 4? Since I know that cosine corresponds to the x coordinate at that location, I would find 45 degrees. Find 45 degrees, and then if they're asking me what is the cosine, I just have to look at the x coordinate. So the cosine of 45 degrees would be square root of 2 over 2. If I were asked what is the sine of 5 pi over 6? What is the sine of 5 pi over 6? I would look to find the degree measure 5 pi over 6, or the angle, sorry. Find the angle 5 pi over 6. And since they asked me for the sine, that's going to be the y coordinate. So the sine at 5 pi over 6 is 1/2. Okay, so that kind of gets us started with how we'll use the unit circle, and that's a ton of information to dump on us all at once, but there we have it. That's our unit circle. That's what's filled in. You will have to be able to replicate this exact page for your next assessment. That the entire grade is nothing but you filling in all of these blanks on the unit circle. Okay, how do I